I'm going to give you a few more examples for section 2.2. So I'm looking in the book at number 72. So we're going to do it together. And it says, find the polynomial function that has the given zeros. So this is one of the zeros, and this is the other zero. I'm pretty sure I did an example that covers the easier type, like 65 and 67, but I know I didn't do one that covers this type. So if these are zeros, that means that x equals 6 plus square root of 3, and that equals x equals 6 minus square root of 3. And then we want to write this back as a factor, so we want to make it be equal to 0. So we're going to subtract 6 and subtract square root of 3 on both sides. So this becomes x minus 6 minus square root of 3 equal to 0. And here we're going to subtract 6 and add the square root of 3 on both sides. So it's x minus 6 plus square root of 3 equal to 0. So these are the factors. So we're going to write them in parentheses. Well, we're not used to using 3 terms for a zero or for a factor. So it's going to be super helpful if we will group the x minus 6's together and kind of make this be in brackets. That way we've sort of got like items grouped together. So we've got the x minus 6's that will FOIL together, and then we'll have the square root of 3's that will FOIL together. So we're going to multiply these two things together. These are conjugates of each other. Now with the way I've written it, it's the same thing and then different signs and then the same thing. So when you multiply conjugates, it's always first times first minus last times last. And so now we just need to square this out, and we'll use that rule. Square the first, multiply these together and double it, square the last. And a square root of 3 squared, squaring a square root undoes it, so it just frees the 3. So the final answer is x squared minus 12x plus 33. So those are some sort of complicated steps. So when you go to work numbers 71 and 73, why don't you keep this handy so that you can look at it and follow the steps that we did. I'd also like to do one like 78 for you. We're going to find the polynomial function that has the given zeros, multiplicities, and degrees, and it says there's many correct answers. So one of the zeros is 5 with a multiplicity of 3, and there's another zero that is 0 with a multiplicity of 2, and this should have a degree of 5. So the first thing we're going to do is take this first fact. If the 0 is 5, that means x is 5. Make this equal to 0. So that's the factor, but it's a multiplicity of 3, which means it's to the third power. Now we'll do the same thing with the other 0. X is 0. It's already equal to 0, so this is the factor. So it's times an x with a multiplicity of 2, so x squared. I don't know if they want us to multiply this all the way out or not. I guess they probably will. So we'll do x minus 5, x minus 5, x minus 5, and x squared. We're going to FOIL these two together. I'm going ahead and combining my like terms. And then I'm going to distribute these two. And then my last step is to multiply this all the way out. I'm going to distribute with the x to the third to everybody. Adding like, when I multiply like bases, I add those exponents. And then we're going to distribute the 5x squared to everybody. With the negative, make sure you're paying attention to that. Your last step is to combine like terms, the x to the 5th, negative 15x to the 4th, 25 and 50 plus 75x to the 3rd, minus 125x squared. I'm not sure. Check before you do all that multiplying if they make you do that in the book. They might let you leave it just like that. All right, the last one I'm going to do is 86. And actually, I think I'll do 90. It looks a little bit more complicated. Alrighty, they want us to sketch the graph by applying the leading coefficient test. So the degree is 6, which is even, which means it'll behave like a quadratic. The leading coefficient is -1, which is negative, which means our parabola is going to be flipped over. B part says find the zeros of the polynomial. So we're going to have to factor to find the zeros. I do not like to factor a polynomial with a negative leading coefficient, so I'm going to factor that negative out and change every term's sign. And this is one of those quadratic-like problems because this power and this power, 3 is half of 6, so it's like a quadratic, where 1 is half of 2. So we can do this like a quadratic. We'll factor it into 2 binomials, x to the 3rd and x to the 3rd, and that's how we'll get that x to the 6th. And 8 will be 8 and 1, minus 8 and plus 1. This is a difference of cubes. You factor a difference of cubes using this formula. A minus b, a squared plus ab plus b squared. I think we did this before Christmas. This was SOAP, same sign as original, opposite sign, and always positive. So this is x to the 3rd plus 1. Ooh, that's a sum of cubes. We'll get that in a second. Let's do this difference of cubes. So it's x to the 3rd and 2 to the 3rd. So that's our a and our b. So we'll be putting those in here. We'll do x minus 2, just plug it into the formula. X squared minus 2x plus 2 squared. So let me put that up here. And this right here, this is a sum of cubes, which also has a formula, which is same, opposite, always positive. So when we write it underneath here, a is x and b is 1. So we'll do x plus 1, x squared minus 1x plus 1. So we'll stick that right up here. And then I ran out of room to write this, but it's times by this right up there beside it. Okay. Please email me if you have trouble, and we'll look at things on Tuesday.